Dark matter, the light we couldn't see, a revolutionary theory by Christian Barrios. In the vast tapestry of our universe, there lies a profound mystery that has puzzled scientists for nearly a century. We call it dark matter, an invisible force that seems to hold our galaxies together, yet remains completely undetectable to our instruments. According to our observations, galaxies are spinning so fast that they should tear themselves apart, yet they don't. Something invisible appears to be holding them together, something that makes up an astounding 27% of our universe's mass energy content. For decades, scientists have proposed exotic particles and invested millions in complex experiments trying to detect them. Yet despite our best efforts, these hypothetical particles remain stubbornly elusive. But what if we've been looking in the wrong place? What if the answer has been right in front of us all along, hidden in plain sight? Chilean independent researcher Christian Barrios has developed a groundbreaking theory that challenges our fundamental understanding of dark matter. Through careful study of optical phenomena and electromagnetic radiation, and with the assistance of advanced AI systems, he has uncovered a remarkable possibility. Dark matter might not be matter at all, but rather an emergent phenomenon arising from the very geometry of light itself. This isn't science fiction. It's a theory built entirely on well-established physics, quantum electrodynamics, and general relativity, requiring no speculative new particles or forces. The key insight came from a deep examination of how electromagnetic radiation propagates through space. When Barrios studied the geometric patterns of light propagation, he noticed something remarkable, something that would lead to a complete reimagining of dark matter. Every point in space is not empty, but rather saturated with electromagnetic waves traveling in all possible directions. These waves, carrying energy according to Einstein's famous equation, E equals mc squared, create an effective mass density through their very presence. This geometric framework explains every single known characteristic of dark matter. 1. Gravitational effects. The energy density of electromagnetic waves creates an equivalent mass through Einstein's E equals mc squared, producing gravitational effects identical to those we attribute to dark matter. 2. Spherical distribution. Just as light radiates spherically from a source, this effect naturally creates spherical halos around galaxies, exactly matching observations. 3. Cosmic web structure. The straight-line propagation of light between cosmic sources creates the filamentous structure we observe in the universe's dark matter distribution. 4. Transparency. Just as light waves can pass through each other without interaction, this electromagnetic structure remains transparent, a key characteristic of dark matter. 5. Historical invisibility. Our detection methods have been dramatically underestimating the total electromagnetic energy present in space, as we only measure the waves that directly strike our instruments. 6. Cold behavior. The reference frames established by radiating sources constrain the movement of this energy density, naturally explaining the cold behavior of dark matter. 7. Perhaps one of the most compelling aspects is how this theory explains the puzzling case of ultra-diffuse galaxies. Galaxies that appear to have little or no dark matter. Under Barrios's framework, this is exactly what we should expect. Galaxies with fewer and dimmer stars would naturally have less electromagnetic radiation and thus less of this dark matter effect. This theory even opens a tantalizing door to understanding dark energy, suggesting that the very same geometric principles might explain cosmic acceleration. But that's a story for another time. Sometimes the greatest discoveries come not from building ever larger experiments or proposing exotic new particles, but from seeing what's already there with new eyes. Christian Barrios's theory reminds us that the universe's deepest mysteries might be hidden not in the darkness, but in the very nature of light itself. As we stand at this potential turning point in our understanding of the cosmos, we're reminded that science advances not just through technological breakthroughs, but through revolutionary new ways of thinking. Perhaps the key to understanding the invisible forces shaping our universe has been shining right before us all along. Theorized by Christian Barrios. Narration script, Claude AI. Voice, 11 Labs.